Hi everyone, welcome back to my channel. So in this video we'll be discussing the types of operators in Java and what are their use cases. Hope you understood why Java is platform independent language. If you have any thoughts, share in the comment section. Okay, let's see what operators are. We have done this program so many times. I've just declared two variables a and b with values 10 and 5. So we know what arithmetic operators are. If I give a plus b, it just prints 50. If I give a, the thing is, we generally use four operators like addition, subtraction, multiplication, and division. For division, we will be using this because this division gives us the quotient, that is 10 divided by 5 gives 2 as a quotient and 0 as the remainder. So to get remainder we will be using this modulo, and to get the quotient we will be using the division. So if you want to get do multiplication, you just use the asterisk symbol, a asterisk b, that is 10 times 5 gives 50. Okay, it's doing that. It's simple stuff, that is arithmetic operators. There are something called logical operators. You will understand this use case when we are doing the conditional statements. That is the next lecture. We'll be seeing about if else if ladder and if else if. So we'll be doing a lot of things over there. So there this logical operators plays a crucial role. Now I'll be just theoretically explaining what logical operators are. Logical operators are used for making some decisions, or it just gives a logical output, and means that the output will be true only if both the inputs are true. Otherwise, it will be false. In programming terms, we consider zero to be false and non-zero values as true. That is one. Mostly, we'll take one as true. Okay, if two inputs are zero and zero, it will be zero because both are false. If one and one comes in as input, in case of and one gives one because both are true. What if one and zero comes? One and zero, the output will be zero because both the inputs should be true to get the output true in terms of and. Whereas in terms of or, it is completely vice versa. That is if both the inputs are false, then only the output will be false. Otherwise, it will be true. In case of not, you will take only one operator. That is only one value. If it is false, it will be changed into true. If it is true, it will be changed into false. That is the use of these logical operators. Don't worry about much. We will be covering them in detail and how to use them in conditional operator and conditional statements in next lecture. Okay, another thing is bitwise operators. Bitwise operators is really useful when you are, want to do things in other scenarios, like when condition happens that you don't need to use these operators like arithmetic operators and stuff, so then you will be using this bitwise operators. So in that cases, bitwise operators plays a crucial role, and we also use them to reduce complexity in many steps. Okay, don't worry about what complexity are, we'll be covering them in the future lectures. Okay, and this is single and. In single ampersand symbol is used to denote the bitwise and operator. So what this do means it's same. 0 and 1 comes in, what will be the output? 0. So as already told in and, it also do the same job. So or also like that, and not also the same case. Caret means it's XOR. That is the symbol is called as caret operator. If any one of the input is true and other input is false, the output will be true. That is, both the input should be there. True and false comes in, the output will be true. If both true or both false comes, the output will be false. So you need differences in the inputs. Left shift and right shift. Okay. Left shift means you are shifting the bits to the left hand side by one. Say, sorry. So a left shift, left shift. See what's happening. 20. How is that happening? Actually, convert 10 to binaries. What will be the binary form of this 10? Let's go from the left hand side. That is 0. This is the binary form of 10, right? So if you convert it, 2 plus 8 gives 10. So this is the binary form. What this actually does means This caret operator is shifting them towards the left side by 1. That is, this 1 takes the zeros position. Like 1, 0 takes the 1's position, 1 takes the zeros position, 0 takes 1's position, and finally there is one more bit that should be 0. So what is this? This is 20. That's why we are getting 20 as a output over here. If I give 2 means it will shift to 2. So it will also come again here, 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 here. That will be happening. So simply understand, if you use left shift operator means the value gets double. So if we use left shift, the value gets double. So south a right shift 1. If we use right shift, the value gets divided by 2. See what should be the output over here? 5. See, 5 is the output. We use this left shift and right shift operators quite few times. So try to familiarize with them. Try to use multiple values over here. I've just given only one. So you could also try doing it with the two other stuffs. So basically what means that it will be 2 to the power. So if you use left shift, so if the value is 10, 10 left shift 1 means it will be changed to 20. So if we do the right shift, it will be divided by 2. So be clear with these operators. And another thing is, say I want to change the value of a by 5. A equal to 10, right? I want to change it. A equal to a plus 5. So what will be the value? 15, right? The value is going to be 15. But this is quite not that much good. A equals to a plus 5. So I could replace it as a plus equals to 5. What this means a equal to a plus 5. That is the shorthand representation. We could do this for all the arithmetic operators like subtraction, multiplication, division, and the modulus operator. So everything we could give it over here. Minus, multiply, divide, and modulo operators as well. Okay, try to use these operators as much as you can. Be familiarized with them so that it will be useful when we are doing the other advanced steps. Hope you understood this video. Thank you.